Alright, so now I've just affixed some tape to this top of the flywheel there. And just want to do a little bit of an experiment. I want to see what happens if I make my own new set of marks. So first thing I'm going to do is I'm going to find where the limit of those two dead spots are, or the limit of that dead zone, so to speak, that area where there's rotation with no movement of the piston at top dead center. I want to find those two limits and then split the difference there, and then that's where I would expect top dead center to be. Not when it first arrives there, but when it's, well, maybe it is when you're supposed to get there, when it first arrives there. But we'll look at all of them, just for the giggles. Okay, so clearly this is coming up. So that right there to me feels like where it stopped moving up. We'll get that line to line up right there. Now let's see where it moves, starts going back down. Right there. So the space between these two lines right here probably only represents, maybe 2 or 4 degrees of rotation. But so this represents where the piston first gets to top dead center. This represents where it is first starting to go back down again. So I'm not sure whether or not I should be here, here, or in the middle. In the middle is what I'm leaning towards. But again, the most disconcerting thing to me about this whole thing is the fact that this darn sticker doesn't line up with anything to indicate that it's correct. This line right here is lining up with that. That's it. So it's weird. So because it's bugging me, I am going to pull the flywheel again and just verify that I'm correct about that being only one way that this could be on here. There's a big washer in there that's in the way. If I could get that washer to oh, I need a small magnet to get in there. Okay, so without a doubt, you can see that there's only one place where the splines are omitted. So there's no way for this flywheel to be installed on this shaft any other way than the way it is right now. Okay. Some things are starting to make a little bit more sense. Did a little bit more research. What I ended up finding out was that right here, where this line is that I was talking about earlier, that seems to be lining up when I get top dead center, that there are actually 3 dots that are actually in the flywheel here, so that if the sticker is completely obliterated, you'll have these 3 dots as a reference point. Now the interesting thing to keep in mind is I've never had this circle of bolts on the top here out on this flywheel. But if you take this circle of bolts out on this flywheel, I'm not positive, but there may actually be the possibility of putting this flywheel on several different ways, which would really screw things up. So keep that in mind. By the way, taking the circle of bolts off allows you to pull the flywheel off without pulling the part that actually has the timing belt gear on it, which consequently makes it a heck of a lot easier to put that timing belt in than the way that I did it in the last episode, or however many episodes ago. Remember, I was having trouble getting this all in. Well, I also have learned that apparently when this is at top dead center, this mark right here should be lined up with apparently this center right here. Now right now it's actually not lined up. It's like 1 tooth off. But furthermore, this mark apparently is supposed to be lined up with that mark, and that's not where it should be. So I know that my timing belt is not right. And then also, supposedly, if you take this cover off, yep, lo and behold, there is an arrow underneath here that I didn't notice before. There's an arrow right there. All right, so see that little arrow right there? All right, so that little arrow underneath there is supposed to point right at the center of the crankshaft. Well, again, confusion has set in. Right now, that arrow looks to be pointing right at the center of the crankshaft where it should be. But this little nub on this thing is not lined up with this nub on here. So if I remove the timing belt and rotate this over one tooth, then I could get these to line up, but then the arrow's not going to point at the center of the crankshaft like the people online that I've been watching claim is supposed to happen. So that's kind of interesting. However, take notice that my two limit marks that I made earlier today are pretty much in line with the center point right here. This all seems to be in line. That's making me think that I do in fact have top dead center. Alright, so what I've done now is I've installed this cover temporarily again, and I've rotated the flywheel so that the three dots, the line with the three dots on it there, lines up perfectly with this black mark right here, which is supposed to be number 1 top dead center. I'm going to remove this, and let's take a look at what that arrow is doing now. Alright, that arrow is now pointing more this way. It's pointing more like this way. So I don't like that. Okay, now I'm getting somewhere. What I've done is I've added a little tiny short extension to the extension rod I already had on there. And the reason why I did that was because I wasn't getting enough travel with the way this is mounted. Because what I wanted to do was use a method I found in another forum where a Marine, obviously the guy's a tech, because he talks about using the dial indicator and mounting the dial indicator, finding top dead center with the dial indicator, and then backing off 0.464 on the dial indicator, and then using that to establish your timing mark. Well, lo and behold, when I do that, the 27-degree mark seems to line up with my timing pointer here. So I thought, well, that seems kind of strange to me. But then I happen to notice something I haven't noticed up until just now, because I wasn't thinking about the number 464. But lo and behold, right here, there's a line and there's a number. And I bet you that if this wasn't all scratched up, it would probably be really clear. And that it says 0.464, that's probably a BTDC. So this is 0.464 before top dead center is that point right there. And right now that lines up with a point right there. So then I saw in the same thread, guy posted an excerpt of the service bulletin that came out where Mercury talks about, you know, detonation causing piston damage and stuff like that due to low octane gasoline now being prevalent in the marine fuel industry, and recommending that timing be changed on all of these older motors when they're in for service to 21 degrees top dead center at I think wide open throttle. So lo and behold, somebody in the thread chimed in and said, well, as I recall, another obviously veteran tech, as he recalls last time he did one of those, 0.104 on the dial indicator was where 21 degrees would be. And I thought, well, that's interesting. So what happens if I bring the dial back, if I go to top dead center and I come back 0.104 on the dial? Well, when I do that, guess what happens? My new mark that I was just talking about is right on the 21 degree line. How do you like that? So, that seems to make perfect sense, except for one problem. Why aren't these lines lining up with this line right here, like I think it's supposed to? Then I saw something else that I thought was curious, where one of the techs in the forum was talking about that at some point Mercury stopped putting these stickers on the flywheels and started putting them on here. Huh. Look at this. I've got stickers on both. I think this is not the original flywheel for this motor. Furthermore, I'm looking at how much I would have to rotate this over in order to actually get this to line up kind of like the way I want it to. And I can't help but notice that it almost appears like it might be about the same amount if I took these bolts all out and rotated this one bolt position over. So I think somebody changed this flywheel. I think they put this flywheel on this motor, and when they put it on, they didn't line this up. They didn't bother lining this up correctly. So if I'm lucky, I could pull these bolts, rotate this over, drop the bolts in, and everything will line up. I can see where the threads actually come through on this side for these bolts. I can actually see the orange paint on them, on the threads themselves, in several spots, indicating to me that these bolts have never been out since this was painted, and this looks like the factory paint on here. So I think that when they replaced this flywheel, which is my theory, that it came with this piece and they just stuck it on just that way. But these are really tight to get out. So I broke them loose a little bit with the breaker bar, and I'm using my impact driver. Now before I do anything, I think I'm going to mount. I'm going to mark how this is on right now. Alright, so this is just like a spacer. Letting it show up. Yeah, so there's all the markings on this thing. So there's no reason I can't put this any orientation that I want. So if I put this, whoops, son of a gun. Thought this piece was attached to that. Now that just popped off and I didn't see where it was for sure. I mean, I think it might have been there, but what a bummer. Scratching. Marking that was pointless. Let's see if I can't see some other evidence here how this was. There is some discoloration from here to here on the dirt that actually kind of lines up with the way this is. Oh, the heck with it. I'm not going to overthink this. I'm just going to put this on, get it, set it at that top dead center mark. I'll probably use the .464 mark, and then set that up like I had it, and then put the flywheel on and see if there's a way I can mount the flywheel onto this so that that mark lines up. Oh, alright, having the flywheel off of this part really makes reinstalling this a lot easier. As a matter of fact, if I take the alternator off altogether, it makes it putting this on a piece of cake, but I actually just fished it through. So anyways, the bad part about having the flywheel off is it's hard to grip this to turn it, so I just stuck a couple of bolts in here, and I've got it back to top dead center. My indicator still looks like it's roughly at 0 there when I'm at top dead center. It's like this 1,000th off. If I go back this way, 464 thousandths. I need something to turn this a little more finely. 450. That should be 464, 465. That should be right near it, right there. Let's see if there's a position I can put the flywheel on where that corresponds to that. All right, well, that doesn't work because if I line up the holes there, here's my .464 mark way over here, and the mark on the cowling or this frame here is way over here, so that doesn't line up. And if I turn it to the next hole position, that's way over here. Now the mark is way the heck, and now the mark is way the heck over here. So I can't get it to fall on that position there. So that's not the answer. Just for the heck of it, before I give up on this, just for the heck of it, I'm going to try the top dead center as the. I'm just going to set it at the top dead center and see if I can get that to line up. But it looks like no matter what I do, I can't get that to line up. So I think what I'm going to end up having to do in the end here is I'm going to have to end up ignoring this sticker on here and rely on this one. Well, let me get this back to top dead center. It should be TDC right there, or within a few degrees anyways of TDC. So 0 is way over here, so that I would want to line up with that right there. Curious how close that is. Oh, the ring gear doesn't fit through this stinker. That's one of the positions that the holes line up in. Let's see how close that is to happen. That's at that's almost at the 27 degree mark, so that ain't it. The 0 is way over here, so I got to rotate this over one hole position and see whether or not anything lines up. Okay, that's one hole position. And what that ends up being is how this originally was put together, I think, because I got the 3 dots lined up with that mark there. Problem is, that's not 0 degrees. 0 degrees is over here. Alright, when those 3 dots are perfectly lined up with this mark here, that appears to be my top dead center, 0 degrees. So I think if I just ignore all of these markings here on this darn thing, I can actually just use this sticker right here. In other words, when I have those 3 dots lined up with, say, 2 degrees or 4 degrees or whatever, you know, I don't know how else I could do it. I mean, if I rotate this, the 464 now, 450, 464. You can see if I put it at 464, you can see that this line is actually right on the 27 degree mark, oddly enough, which is interesting because that's also the max advance, maybe, I don't remember. Okay, anyways, the 3 dots, by the way, are now located and line up with like the 45 degree mark. Which, God knows where that is on this sticker. This sticker only shows up to 27. Hey, you know what? It's interesting. That 464 is lined up with the scratch mark I have right here. So if I line that up so that the 27 degree is on the scratch mark. Do my 3 dots point to 27 degrees over here? Yeah, they sure do. Huh. Alright, I can't spend the rest of my life screwing around with trying to figure this out. I think I could push on forward if I just teach myself to ignore this label, use this label that's on top here, and use those 3 dots as my mark on the flywheel. Hey everybody, here's an update where we stand right now. I've made some headway with this whole timing issue here on the inline 6. Most of that headway has taken place just with some further research and watching some other videos. So some of the initial information that I had gotten was culled from videos that I found on YouTube. There's a gentleman I forget what his channel name is, but apparently he had one of these, and he kind of went through what I'm going through, which is that he started out with not really knowing a lot about these engines, and then kind of like over the arc of the whole experience of working on his engine, he went through some major stuff with his. He at one point ended up having to abandon his entire block assembly and get another engine, and then he went through a problem where he had a bad trigger in his distributor and had to trash that, and it was just he did a lot more work than I would have ever done to this old motor. I think it was funny. That was one of the things I found with his videos, was that a lot of the information he put out initially was incorrect, and he often said that he wasn't sure about it. And then what he was apparently doing was he was going on a website dedicated to the type of boat that he was working, that he had, I guess. I think it was called the Sidewinder, if I'm not mistaken. But anyways, then he'd get more information, and he ended up hooking up with one or two, I guess, guys who had a lot of experience with this motor, and gave him some really good information and advice, and helped him figure out how to link and sync his and do all of that. So I made a lot of notes here based on what he had found. He also illustrated how, if you're missing your sticker on your flywheel completely, how to go about making up the markings and stuff like that. In addition to that, I went out to a lot of other forums and culled information from several guys who, based on their replies, obviously knew what they were talking about working on these motors. And what I've come to the conclusion of now is that this flywheel, I don't believe this flywheel is the original flywheel to this motor. And I believe that this flywheel, the sticker on this flywheel, is actually for a motor that would have had a something referred to as a timing pointer, I think. And what that basically is supposed to be is it's supposed to be I guess on the later ones that were even plastic, and they were kept in the pouch that has the pull start cord, from what I read. And oftentimes they go missing or get lost, and it's something you would apparently temporarily install at a mounting point here on the motor, on the block, and it would sit over here and actually give you an indicator point. And then what you had to do is you went through a procedure using the dial indicator to set that pointer to the correct spot. Okay, that's what the .464 is that you hear a lot of guys talk about working on this. The .464, some guys believe it's just an arbitrary number that Mercury engineers or whoever pulled out of their hat. The idea is that it's a point not at top dead center, away from top dead center. I guess early on I talked about that when it's at top dead center, there's that little brief point where the piston's at the top and that connecting rod is making its pivot as the crank comes around. So there's a very brief point there where the piston is at top dead center and is not moving up or down, but the crankshaft is still in rotation a little bit. So that's why they don't want you setting the indicator based on top dead center. They want to try and remove that from the equation. So what they did was they picked a point somewhere where the piston is now either not quite at top dead center or on its way down. I forget which. Well, this is before top dead center. So they're picking a point somewhere in the travel of the piston a little bit further down. How far down? 0.464, or 464 thousandths as measured with an indicator from top dead center down. So the procedure is you mount the indicator, you bring it up to top dead center, you set the indicator to 0, you bring it down a little past 0.464, and again the reason why they want to do that is they want to take out the error that's in the bearings, the clearance in the bearings, and then you come back to the 0.464. At that point, you then would set your indicator to line up with the line on this flywheel sticker that I've showed you many times, it says 0.464. Once you set that indicator, then at that point, you're now able to, all of the other timing marks should be correct. And I verified that last night. So that's the deal there. And let me show you how I ended up doing that. So the first thing I did was I remounted my indicator mount. You'll notice, some of you may notice it looks a little bit different. I had the rod coming up here and the rod coming down at an angle. And what I did was I now mounted it so that it's not quite perpendicular, but it's more perpendicular than it was, because, and actually I think I might readjust that this morning to make it perfectly perpendicular. And the reason why I want that perpendicular is because I'm trying to measure the travel of this piston going in and out this way. If I have the indicator at an angle, which, you know, I didn't have it at a severe angle, but I wasn't able to get right on the very top dome of that piston. And what was happening was, when I would get to the very top and bottom, that rod at the base of the indicator, I think it was moving a little bit on that little edge. So I was getting a little bit of like jump on the needle, and I didn't like that. So that's why I changed this setup. And I'm going to tweak it just a little bit, because I'm noticing now that that is still not perpendicular. I want that perfectly perpendicular, and the way that that's accomplished by the technician is, rather than putting the indicator in a stand like this, apparently there's a service tool that is made to screw into the spark plug hole, and then the indicator mounts to that in a way. So I don't know what this thing looks like, but one of the guys online was saying that, hey, the reason why he's not doing it that way is because it's like $150 to buy this service tool. And anyways, it keeps the perpendicular, keeps the indicator perfectly perpendicular, and it takes out any of the error that might be caused by any of this little bit of free play here. All right, so let me tweak that setting. Okay, so now I've reset the dial indicator so that it's perpendicular in both the X and the Y axes to the face of the piston, and it's perfectly in line with the travel of the piston, or as eyeballing it, it's very close. It's maybe a couple degrees off, which will cause a negligible amount of error. So now that I've got the indicator set up, and I made sure that I have enough travel for at least the 464 thousandths setting that I need to do, I can now use the 0.464 to set my pointer. And I actually don't have a pointer on here, so I made one, and I'll show you that in a moment. So the process is, we're going to turn clockwise, which is the normal direction of travel of the flywheel, okay, until we get to top dead center, which is right there, okay? Now, from there, we're going to turn counterclockwise. We're going to back off to 464 thousandths, but then we're going to go past that a little bit and come back to it, so we can take up that free play in the connecting rod. That's the clearance in the connecting rod bearings I'm talking about. All right, so
1, 2, 3, 4.
And that's about a quarter turn past. Now I'm going to come back to 464. And you don't want to get any closer than that trying to rotate it by hand, because what's going to happen is, because of the sticking of the piston in the cylinder, you put a little bit of rotational force on it, and then all of a sudden it gives and it shoots right past where you want to go. So I'm just using a pin and tapping lightly. There's my 464. I'll show you my pointer.